Sort out and solve Cambridge IGCSE Physics Paper 2 multiple choice extended version, and the variant for this paper is like 0625/22 October November 2022. So let's start off with our first question. Which measuring instruments are suitable to determine the volume about 200 ml of liquids and the diameter of a thin wire? So we need to find out the right answers, the right instruments for this MCQ. So for volume you will be using measuring cylinders, yes, but you cannot use these things. For diameter you are going to use again micrometer screw gauge, so this is going to be your right answer. The diagram shows speed time graph for 4 different bodies moving for 6 seconds. Which body travels the least distance? So these are the graphs. So let me zoom out so that we can see in these pictures. So we have to find out the least distance traveled by the object. So in the first case, so that will be area of a triangle, and that is going to 1 over 2 times base times height. The base will be 6 and the height will be 8. So if you do the calculation, 48 divided by 2, which is 24 meters. Okay, now we will do for the next one. It's going to be, there are two triangles, so this is going to be 1 over 2 base into height plus 1 over 2 base into height. So first one is the base is 4 and the height is 8. 1 over 2, the base is 4 and the height is 8. So this is going to be like, if you cancel it out, 2 on the 2, it's the 16. And for the next one is 4 to 6. So for the next one is 4 to 6. So this is going to be 2 and height is 4. So you can see this thing, that this is the height, which is 4. So 16 plus 4 is 20. So 20 meter is this. The object has covered this distance in this scenario. Okay, there's the where's the graph. So you can see the graph is over here. So now you can easily multiply the for this you have to use the area of rectangle, that is length times breadth. So length is around 6 and breadth is around 8. So 6 times 8 is 48 meters. And the last one is like, you can do this thing, make two rectangles. So first rectangle will be 4 times 8, which is going to be like 32, plus 6 minus 4. So this is going to be 2 times 4 and it is going to be 8. So this is going to be 40. So out of these you can check the option B is your right answer, because it has the least distance covered. Okay, I hope this is clear. Which statement describe the relationship between mass and weight? So we have to find out the relationship between mass and weight. Mass is the effect of gravitational field on the weight. Mass is the effect of magnetic field on the weight. Weight is the effect of gravitational field on the mass. Yes, this can be the right answer, seems to be. And weight is the effect of magnetic field. No, this is not the right answer. Magnetic field, remove these two. Now option A and C can be the right answer. So mass is the effect of gravitational field. No, mass does not depend upon the gravitational field, so this is not right. So this is the right answer for this question. Okay, the diagram shows 4 pieces of laboratory apparatus. Which piece of apparatus is used to find the density? And density is, the formula for density is equals to mass over volume. So we need to find out the balance and measuring cylinder, not ruler, not stopwatch. So option B will be the right answer. The diagram shows the meter rule Mn on two sports P and Q. So these are the two sports P and Q. Two loads are placed on a ruler as shown. The rules rest steady on the sport. Which row is correct? So we have to find out which row is going to be the correct one. So total momentum about M is clockwise. Okay, and okay, the thing is this, the rule rests steadily on the sport. So this means that the rule is what? At equilibrium. So we know that at equilibrium the sum of all the forces are equals to 0, or sum of all the moments are equals to 0. Sum of all the forces are equals to 0, or sum of all the moments must be equal to 0. So total moments about m and total moments, this is going to be the right answer, because I have already mentioned and I have already told you that whenever the object is at equilibrium, so the sum of all the forces acting on that object must be equals to 0, or the second condition, the also sum of all the moments acting on the object must be equals to 0. So this means the object is at rest, it's in equilibrium, so the moment will be equals to 0. The diagram shows an object is moving at a constant speed in a circular path in the direction shown. A force acts on the object to keep it in a circular path. So again, whenever an object is moving in a circular path, so the direction of the direction of the resultant force will be toward the center, because the object is moving in a center in a circular path. A trolley of mass 4 kg traveling with a velocity of 4 meter per second collides with a trolley of mass 2 kg and traveling with velocity is 2 meter per second in the same direction. After collision, the velocity of the 4 kg trolley is reduced to 3 meter per second. So what is the velocity v of the 2 kg trolley after collision? So what we are going to do is, we are going to apply the formula law of conservation of momentum, and that formula or that law is m1 u1 plus m2 u2 equals to okay, for first we are going to solve this, that is before collision, the momentum before collision. So it's going to be mass of the first trolley times the initial velocity of the first velocity plus the mass of the second trolley times the velocity of second trolley. These are initial velocity. U stands for initial velocity. Both are initial velocity. So 4 times 4 is 16. 16 plus 4 is 20. So it means that before collision the momentum was 20. So after collision, what we are going to do is, after collision the mass m1 v1 plus m2 v2 over here. So we know this thing, after collision what is going to happen, the velocity of 4 kg has reduced to 3 plus the mass of the second trolley, which is 2, and we need to find out this velocity. So this is going to be 12 plus 2v. So now we compare these things, before collision equals to after collision. This is the law of momentum, law of conservation of momentum. So that before collision the value was 20, after collision this is the thing that we need to write it down over here. So 20 minus 12, and then we divide it by 2. So the velocity will be 8 divided by 2, which is 4 meter per second. So option B is your right answer. An object falls toward the Earth's surface. What happens to the gravitational potential energy and to the kinetic energy of the object? So obviously the height of the object is decreasing, so does the gravitational potential energy, because it depends upon the height, and the object is moving faster and faster toward the center of the Earth, so the kinetic energy will be increasing. A boy takes 0.6 seconds to lift a block of mass 0.6 kg from the top of the desk and place it on a shelf. The top of the desk is 0.8 meter above the floor, and the shelf is 1.7 meter above the floor. The gravitational field strength is 10 newtons per kg. What power does boy develop? So in this question, what we have to do is, first we have to find out this height, which is 1.7 minus 0.8, which is equals to 0.9. okay, so we know that power is equals to, because they are asking about power equals to work done over time, and over here we will use the potential energy formula for work done, which is going to be mgh divided by time. So what is the mass is going to be like 0.6 kg, then value of g is 10, which is also given, and h is height is 0.9, and then you have to divide it by 0.6. so this will end up at 9 watts, because 0.6 will be cancelled out with this. So 10 times 9 is 9 watts. So Option C is your right answer. A man is lifted. A mass is lifted from rest on the ground to Y. There is no air resistance. P is the increase in gravitational energy of the mass. Q is the kinetic energy. Which expression is equals to mechanical work done by the mass? So you see this thing. We have studied that mechanical energy is equals to kinetic energy plus potential energy. So if you add both energy, so it's going to be like P plus Q. So this is option A will be your right answer. The diagram shows a tank containing seawater tank. This is the height, and the density of the seawater is this. What is the pressure at point P relative to the atmospheric pressure? Okay, the diagram shows a tank containing seawater. The density of the seawater is 102 kg per meter cube. What is the pressure at point P relative to the atmospheric pressure? So we know that the formula for pressure in liquids is equals to rho g h. Rho is the density, g is the value for g is 10 meter per second square, or you can say it's the acceleration due to gravity, and h is the height. Okay, so applying the values or putting the values into this question, so it's going to be like height, which is going to be 8 minus 0.6, because both should be in the same units. So this is going to be 75480, which is approximately 75,000, and so this is option C is going to be the right answer for that. The pressure of a fixed mass of a gas in a cylinder is measured. The volume of the gas in the cylinder is slowly decreased. The temperature of gas does not change. Which graph shows how the pressure of the gas changes during this process? So you can see, or you can imagine, if this is the gas, if it is the container, so if it has gas pressure inside it, okay. So but when you decrease the volume, so pressure will increase. So over here we can't see this change, so this is not the right option. From the option B, the initial pressure is not going to be zero, so this is also not possible. Option C can be possible, but let me check. And option D cannot be possible, because the pressure, as you decrease the volume, so pressure will increase. So over here, the pressure is not increasing; it's decreasing. So option C is your right answer. Wet clothes are hanging outside to dry. What are the best conditions for clothes to dry more quickly? So obviously the wind speed is going to be more. We need that, and the temperature is it should be high as well. So if you see this thing, option A is going to be the right answer, because in summers the temperature is high, in winters the temperature is low. So the whenever you try to dry up your clothes, so in summer they dried up quickly. Which change in design of of a liquid in glass thermometer make it more sensitive? So for this, a larger for sensitivity, a larger reservoir is required for the to increase the sensitivity of the thermometer. A scientist is determining the specific latent heat of vaporization of a liquid. He puts the liquid in a vacuum flask and heats it to a 100-watt heater. The mass of the liquid in the vacuum flask when it starts to boil is 300 grams. He continues to heat the liquid for a further 12 minutes, after which the mass of the remaining liquid is 100 grams. What is the specific latent heat of vaporization of the liquid? Assume that all the thermal energy from the heater is used to vaporize the liquid. So first of all, we will be looking at what is given. We have power, which is around 100 watts. Then is the mass, which is 300 grams. So we will be converting that into 0.3 kg. Then is the time, which is 12 minutes. So we will be again converting into 12 times 60, which is going to be 720 seconds. and the formula for the latent heat of vaporization is Q is equals to mLF. Okay, but before that we are going to be looking for the power, which is work done or energy over time. So power times time is equals to energy. So energy will be 100 multiplied by 720, so it's going to be 72,000 joules. This is going to be your energy, and then we are going to apply the formula of latent heat vaporization, this one, and it's going to be like 72,000, because it's the Q is the amount of heat energy. Then we are going to use the mass, because we need the latent heat of vaporization, so LF will be here and the mass is going to be 0.3. Okay, for this I have done a mistake. So it's not going to be 0.3, it's going to be the remaining mass. So you see this thing, there is a 300 and this is 100. So what is the difference between 300 and 100? That is going to be 300 minus 100. So the available mass is going to be 200 grams. So you need to divide it by 1000 to make it in kilograms. So when you do the calculations, so it's going to be 360,123 joules per kg. So now you see the option number D is your right answer for this question. Which piece of equipment is designed to produce a type of electromagnetic wave? So this is again electric fire, because it's a repeated question, and if you do the topic is radiation. The transfer of heat is due to electromagnetic waves. Uh, a sound waves travel from air into water. Which row describe what happens to the frequency and the wavelength? So frequency will be remain same, but the wavelength is going to increase. So remember this thing. Whenever the sound it's going to travel from one medium to another, so it's going to be the frequency will be same and the wavelength is going to be increased. The diagram shows plain water waves in a ripple tank passing through a gap between two barriers and spreading out. Which name is given to this effect? So obviously this is the diffraction concept. A ray of light travels from air into a material as shown. What is the refractive index of the material? Okay, now first of all thing is this, most of the students they make this type of mistake. So I'll draw it with the red pen. So the ray of incident and the normal, that is called angle of incident, and this is right, because again the ray of refraction, ray of refracted, or you can say refracted ray, that and the normal is going to be whatever the angle in between this, that is called the angle of refraction. Okay, so what is the refractive index? So again we have sine 50 sine I over sine R. So this is going to be sine 27, which is going to be 1.68. If you round it off to two significant figures, so it's going to be 1.7. So this is going to be your answer. The diagram shows an object in front of a plane mirror at which labeled position is the image of the object formed. So again, if you see this is the object, so the person is going to look at the image over here. So you can see this thing, the distance is going to be like this distance and this is going to be equal distance. So object can be seen like this. So B is going to be your right answer. The angle between an incident ray and the surface of the plane mirror reflecting the ray is 70 degree. What is the angle of incident? So now you see this thing, the angle between incident ray and the surface. So incident ray and the surface is 70. So they are asking what is the angle of incidence. So it's going to be 20. So I have already mentioned you this thing, that this ray of light and the normal, they are going to make the angle. So it's going to be A. Okay, moving to the next question. The diagram shows the A molecules in part of a sound waves at a particular moment in time. Which statement is not correct? Earlier there was a compression at X, yes. Later there will be a refraction. Okay, so this you can say there is okay, that's also fine. This part of the wave is traveling horizontally across the page. So this part of the wave is basically traveling like this, and this part is of the wave is traveling toward the top of the page. This is wrong. So that is not correct. So this is the right answer. An object is reflected in clear mirror. What description of the image is correct? Diminished and real. Enlarged. This is not true. Diminished is also not true because you do not get a small image in a plane mirror. Okay. Same size and real. Yes, this is right, but it's not real. And same size and virtual. Yes, this is the right answer. A 100-meter race is started by firing a gun. The gun makes a bang and a puff of smoke at the same time. When does the finishing judge see the smoke, and when does he hear the bang? He sees the smoke almost immediately. Okay, so this is possible. This and this is possible. And let's talk about the hear the bang almost immediately. This is not possible. He cannot hear the bang immediately. So the option B will be the right answer for that. Two magnets X and Y are placed at the end to end on a bank. The diagram shows the magnetic field pattern between the poles of a magnet. Which row shows the direction of the force exerted on X and Y by the magnetic field? So you see, if you talk about the forces on X, so the force is going to be like this, and force on the Y is going to be like this, because they are the north and south pole, so they are going to be attracting with each other. So this is going to be the right answer. They are not repelling, they are not this is the only force that is showing the attraction, because the rest are repelling or going in one direction. The diagram shows the circuit used to control the potential difference PD across a lamp. The variable resistor is adjusted until the potential difference across the lamp is 6 volt. The current in the lamp is 0.5 ampere. So let's do this. V is equals to IR. We need to find out the resistance. V divided by I equals to R. V is equals to 6 divided by 0.5, which is going to be 12 ohms, and the units of resistance is ohms. So option D is going to be your right answer for that. A charge Q flows from the time t through the resistor of a resistance R. Which equation gives the current in the resistor? So obviously we know the definition of current is flow of charges per unit time. So it's going to be the C. A plastic rod is rubbed with a dry woolen cloth. The rod becomes positively charged. Which statement is correct? Electrons move from cloth to rod. No, electrons move from rod to cloth. Is the right answer, and there's no need to worry about the proton things. Okay, which diagram shows the graph of a current against the voltage for a filament? So now you remember this thing. For a filament, you need to understand this thing. As soon as it's not going to be constant, the graph for current and voltage, and it's not going to be increased, it's not going to be constant as well, but it's going to be the D is going to be the right answer for this. Each potential divider is placed in a circuit with a power supply. Which potential divider makes the potential difference PD across the component Y increases when the light intensity increases? So over here the option A is the right answer. Why? Because when the light increases, so you see when the light increases, so voltage is going to be increased, the potential difference. So when the voltage is going to increase, so the resistance is also going to be increased. So this is how you solve this question. Okay, the diagram 1 is a circuit diagram showing an AC power supply connected to 4 diodes and a resistor. The diagram 2 shows the output voltage from the power supply. Diagram 1 is like this. Okay, so first of all you need to know the function of a diode. That is, let's suppose if this is your diode, and if you are giving positive, so it's gonna allow the positive charges to flow. But if you try to bring these negative charges to pass through, it will not allow that thing. Yes, it can allow if you connect it like this. So again, if you see this thing, for positive to flow from this type of diode is not going to be possible. It's not allowing, it does not allow the current or the positive charges to flow. Yes, it can allow the negative charges to flow from this thing. Okay, so by using this, we have to find out which graph correctly shows the voltage time graph curve across the resistor R. So you see this thing, if this is positive, let's say AC voltage, this is positive, so it's going to allow this thing, but this is not going to allow that thing. Okay, so this positive will go over here, and this does not allow as well. So then positive will go over there, and it's going to move into this direction, and then it's going to be negative again. Okay, so this is not going to allow, but this is going to allow. So most probably the diagram for this type of curve, you have to see this thing that it's going to be the B, because it's going to convert the negative. This circuit is going to convert the negative graph into the positive things. Okay, so this is how you do this thing, and you will end up with this figure. Which diagram shows the circuit symbol for a fuse? So for a fuse is going to be this one. This the first one is the resistor, second one is variable resistor, and the D is going to be your right answer. Uh, the diagram represents an alarm system using a logic gate, temperature sensor, logic gate. The data for the system is shown over here. The siren sounds when there is an indication of fire. Okay, and which logic gate is going to be used. Okay, so for this scenario, you can see this thing. Okay, if the temperature sensor is hot, and the smoke detector, there is smoke as well, and then it's gonna play that sound. Okay, so this means that you need to use what. Okay, hold on, let me do some working over here to find out which type of gates can be used. Okay, now you see this thing, if the temperature sensor is hot, and you don't detect a smoke, so the logic gate should be on, and then you will listen to this alarm sensor. Okay, now if you do the opposite of this, 0 and 1, so if this 0 goes into this gate and this gate, so what will happen that if you see the alarm logic gate should allow give you the output 1 again, so that the siren can ring. Okay, now if you do, the temperature sensor is hot, and you can find the smoke detector, so this is like this. And if you do the 0 0 thing, so it does not allow that thing. So I would suggest that the OR gate would be perfect for this, and the answer would be B for this. Four small compasses are placed around a solenoid. A current is now switched on in a solenoid, which diagram shows possible new direction of compass needles. So now you see this thing that when you switch on, if you have started this, the bar magnets act as oh sorry, I mean to say that the solenoid acts as a bar magnet. So in this scenario, I will option A cannot be possible, because if you do this thing, if you make the diagrams for the magnetic field, this is north pole and this is south pole. So you see this thing that the direction of the compass would be not like this in this scenario. So this is a doubt, and B is not the, maybe C or D can be right answer. So it's going to be like if you use the right hand grip rule, which is like you find out the direction of the current, and then you do the bring out your right hand, and you curl your fingers in the direction of the current, then the thumb will tell you which one is the north pole, and which one is the north pole will be your thumb will be pointing towards the north pole, and your the other side will be your south pole. So option D is the right answer, because if you do this thing, then you will be able to understand this how it's going to be the right answer. So remember this thing: north to south, the magnetic field is north to south outside the magnet. So if you are talking regarding south to north, so it's going to be inside the magnet. So magnetic field will, the field direction will be inside the magnet if you are talking about south to north. Okay, transformers are used in transmission of electrical powers to houses. Which type of transformers is used at the power station prior to the connection to the power line, and which type is used prior to the delivery of house? So for power stations, you use step up because to avoid the losses, avoid the energy losses, heat losses, and eddy currents. But before the houses, you do the step down, because let's suppose if a dam has created 200 volts, so you are going to step up the voltage so that it can travel to the residential area, and in the residential area you do the step down transformer over there, so that we can use 220 volts. So let's suppose this is 2000 volts. Okay, so now this is going to be like 220 volts or 1110 volts. This is how you do it. So this is for the residential areas. The diagram shows an AC generator rotating in a clockwise direction. What are the names of the part 1 and 2? So the names of the part 1 and 2 is this is simple, is brushes and slip rings. A thin metal of foil is placed in a vacuum. Alpha particles are fired at the foil, and most goes straight through it. A very small portion of the alpha particles are deflected. So, what does this provide evidence for? So, the evidence is that there is a tiny nucleus in each atom. This is what you get it from this experiment. A radioactive element 230 is represented by the symbol this. This isotope is a radioactive and decay to radium by emitting alpha particles. So what we are emitting is alpha particles. So we know this thing for alpha particle is going to be 4 and 2. Okay, so which nuclide is produced by this decay? So now we can see this thing, like let's suppose we talk about this one, first one. So it's going to be like, if you do this thing, so this is going to be 226, and this is going to be 88. So this is going to be like 230 and 90, 230 and 90. Okay, so 230 and 90, 230 and 90, this is the one, 230 and 90. So if you decay this thing, so you will end up with this one. Okay, we got this. So when this is going to decay alpha particles, so it's going to end up with this for option number A. The diagram shows a piece of apparatus used to determine the nature of the emission from the radioactive source. The absorbers can be raised out of or lowered into the path of the radiation from the source to detector. The apparatus is evacuated. Okay, the table gives a set of results for a particular radioactive source. This is a detector, vacuum, and different absorbers. So this is the radioactive source. So this might be going like this: the radiation absorber in use, none. So and then the count rate was 350. When it was like thin paper, the count rate was this. When it was 1 mm aluminum sheet, so it was like this, and lead, it was this one. Which type of radiations are being emitted by the radioactive source? Is it like alpha and beta, alpha particles only, beta particles, and gamma or beta? Okay, so now you see this thing. For alpha, it has very less range, but for beta and gammas, they have a range. So now you can see this thing. The gamma rays can pass through the lead thing as well. So this is like for beta, and this is for, like you see, for alpha. If this has number has reduced, so this means there was alpha particle as well. But when you kept this thin piece of paper, but the count rate wasn't reduced, so this means there might be beta. And when you talk about this one, so it's going to be like, you see that it has reduced, and gamma. So option C will be your right answer. Okay, moving to the last question, and that states that the graph shows the measured count rate of radiation from a source containing a radioactive isotope. The detector is in a laboratory with no shielding from the background. What is the measured count rate after a time of one half life? So now you have to add that background radiation and the radiation of the radioactive element, and then it's going to be divided by 2 because half life is basically that's it. So D is going to be right answer. Okay, that's it, and thank you very much for watching this video. And if you have any queries or questions, you can write down in the comment section. I will be answering that questions. So thank you very much, take care, bye bye.